As the world moves to more sustainable energy sources, offshore wind is becoming big business. By 2030, the UK government plans to have 40 gigawatts of offshore wind energy capacity installed, enough to make the country run almost entirely on renewable energy. When offshore wind farms are far away from the population centres that consume the most electricity, transmitting the power back to shore can be a real issue. Sending hundreds of megawatts through hundreds of kilometres of undersea cable needs advanced systems and technology that are only going to become more important as we battle against climate change. In order to transmit this power to shore efficiently, it must be converted to a very high voltage and from AC to DC. This is done with a type of substation known as an HVDC converter station. These converter stations are extremely dangerous places. Standing almost 30 stories tall in the middle of the ocean, they're filled with converters running at hundreds of thousands of volts. This makes maintaining these stations not just dangerous, but expensive. Technicians have to be flown out on helicopters even for routine inspections, and landing a helicopter on one of these platforms is no mean feat. We set out to find a better way, and today we're proud to introduce Lima. Lima is a VR-based system for real-time inspection and maintenance of offshore substations, allowing technicians to walk through the substation interior, take sensor readings, and even control a robot that lives permanently on the substation. Once you put on the goggles, you're transported right to the station and can explore the area or get a closer look at one of the converter modules. The whole environment is interactive and all you need is your hands. Want to take a voltage reading? Just point and click and real-time sensor data will be pulled down from the cloud and pop up right in front of you. Lima represents the future of how humans will deal with hazardous spaces. The technology we developed isn't just limited to substations, it could be quickly deployed for nuclear decommissioning or to prepare for a challenging rescue mission. Let's take a look at how it works. Lima has been engineered from the start to be flexible, scalable and reliable. At its core is a versatile cloud system that handles all of the challenges of working between the real and virtual worlds. A network of sensors on the substation connect to each other to create a mesh network that lets each sensor upload data to the cloud. If one sensor goes down, the network adapts and the data can still get through. All sensor data from the substation is logged in a database, while simultaneously being sent to the VR system, allowing users to see the exact data they need, all in real time. As well as this, data from all sensors on the station are fed into a machine learning AI. If it detects a fault or to simulate an issue when training technicians, signs in the virtual environment will alert the user to the fault. This AI is incredibly accurate and can respond to faults almost immediately. The robot's position and movements are also handled using our cloud architecture. Wherever the robot is on the substation, its position is tracked using motion capture cameras in the ceiling. Back on shore, the robot's position is shown in VR, and the user can click anywhere on the floor and the robot will drive there. In order to reach the submodules, which may be 5 meters off the ground, the robot can launch a drone that will fly up and photograph the modules before landing back on the robot. These photos get logged in the cloud and can be inspected in the virtual environment. Lima gives the opportunity for essential work to be done safely and remotely. Not just saving money, but keeping people out of harm's way. It's just one of the things that needs to be done to power countries renewably, and we hope you like it. Thank you.